senior in mechanical engineering. I'm the Group 2 reporter for the jet engine gas turbine experiment. So here is just a sort of brief picture of the jet engine and how it works. The air enters the engine air intake, it gets compressed by the compressor, by the centrifugal compressor. It's mixed with the fuel and combustion chamber. It creates a thrust which drives the power turbine, and then it goes into the thrust transition deflector, causing the thrust to drive the free turbine. It drives the electrical alternator, creating electricity at the end. So here's a sort of diagram of some of these sensors that measure data across the system. There's pressure and temperature sensors sort of scattered throughout. Some limitations for the engine and the generator. There's a max RPM for the engine of 82,000. There's min and max air pressures, inlet temperatures, a minimum fuel pressure, and for the generator, max operating RPM with an automatic safety shut-off RPM. Brief procedure. So first, sort of check the area is safe to verify and suitable for operation. Make sure the MIDAC is set up and have the required PPE, the hearing protection, safety glasses. Do a visual inspection, check the fuel and oil quantities. And then to start, you press the green button, increase the throttle to the maximum, slowly reduce it, and then increase the throttle to your 3 sets of RPMs it tested at, which were 45, 55, and 65,000 RPMs. And you collect the data for about 10 to 15 seconds for each of those. And you could shut off after that. So the data analysis preparation, the fuel type is kerosene, its energy content per unit volume is 139,000 kilojoules per gallon. Its density is 800 kilograms per cubic centimeter or per cubic meter. The air pressure at the start of the experiment was around 1 ATM. So here are some of the plots that I created, showing the compressor inlet and outlet temperature the first time, and also the inlet and outlet pressure. You can see that the pressure and temperature sort of rose dramatically going through the compressor from the inlet to the outlet on both sides. These plots are the turbine inlet pressure and outlet pressure, as well as the temperature. And for these graphs, pressure dropped dramatically going through the turbine from about 50 kilopascals to down to about 5 kilopascals. And then temperature dropped slightly, about 30 degrees Celsius going through them. So more graphs of the second turbine exit pressure, and the inlet pressure comes from the exit pressure and temperature of the turbine 1. It's the same. So you can see that the pressure sort of remained constant and varied, and the exit temperature sort of grew at a steady rate. Then you can also see the fuel flow first time graph, where it also varied between a minimum and maximum, a very small variation, and the engine RPM, which only changed about 200 to 300 RPM, so it stayed pretty constant even though it looks like there's a big change. The generator RPM versus time also stayed pretty constant, just varying around 3 to 4 or 5 RPMs throughout the process. The current voltage and time produced by the generator also remained pretty constant throughout the process. And then here's just some data points from a time selected where the engine RPM was at a maximum for the 45,000 data. Just sort of picks a point on each of those graphs where the engine RPM was at a maximum. So here's a system analysis for the data. The specific enthalpies each cycle point of H1 to H5 are shown. The work done by the compressor at the bottom here pretty much goes through each of these cycles, 1 to 2 of the compressor, 2 to 3 for the combustion, 3 to 4 of the turbine, and then the thermal efficiency I calculated to be around 25 to 25.7%. Here's just a few more graphs of the generator RPM and engine RPM for the generator. Just more graphs. And then another marker of data from the graphs. So the conclusions, the pressure rose as each of the RPMs increased for the 3 tests, along with the temperature, and the power increased a good amount from the 45,000 all the way to 65,000 from 0.14 watts to 45 watts. References.